All right, so this is the workspace where I'll be running the process, and this workspace has like few lake houses. So there are like one, two, three, four lake houses. I think this lake house has no tables. I'll show one of the lake houses. I'll show this Spark internal lake house. So this lake house has two tables: NYC taxi and Z underscore order. So Z underscore order has data partitioned across age values, and NYC underscore taxi, this is just a single table and has almost like half gigabytes of data. All right, and this is my code, and this the first setting is the client ID. So this client ID will be the service principal ID. The CSV location, the CSV location is the location where the data for where the metadata and other details would be exported to CSV and stored. So this is the location. All right, and this is the workspace name. Okay, I'll run this application. So the first thing it's gonna do is that it's gonna prompt for a browser credential. I mean your Fabric tenant credentials to generate the bearer token. So once authenticated, it starts analyzing the lakehouses across the workspace. So it has process sales underscore data table, the case record z underscore. It's processing the z underscore table. As you can like I mentioned, it has like multiple. Um, I mean, the data is partitioned across my age values. And if you see here, so like let's take an example of this of age 48. So they're like processing three files, right? So what I've done is that I had created multiple files across every partition. So as you can see, there are like multiple archive files across every partition. So this is standard across every partition. Okay, so it started processing NYC taxi. So this data is this table is pretty huge, and also my internet is not so fast today. So this is going to take some time. And this table has only one file, I guess. It has only one single CS Parquet file. Let's check. Yeah, there's only one Parquet file. Yeah, it's done. And let's check the data, the CSV file. Yeah. So there are like three lake houses. Every with these two lake houses only having single table, and these two lake houses having this lake house having two tables. So it has the number of column. It checks if is B order is enabled. So you have true, false, and true. So I had explicitly disabled B order for this table and the number of files. So since this data is partitioned across age value, say number of files are quite more, and the total size of the files. So based on this values, say for example number of files and the total size of the files and the partition on which the table is partitioned on, you can kind of uh, interpret if it's a small file problem or not. So I haven't decided upon. I mean, I haven't put in the logic wherein you can explicitly say if this is a small file problem or not. It's on a case to case basis. Based on this data, it's quite easy to interpret. All right, so it gives the the row group count and the total size across each row group, and yeah, and also it has this z order by. So this helps you identify on which column the table is as z ordered by. Yeah, and one thing that I also mentioned in my article is this the date time problem. So I had faced the same issue in an earlier article wherein I demonstrated the use of, it was kind of an introduction to the use of the ADLS Gen2 API storage APIs. So in that also I had faced this problem. So the text data is not getting generated, is not getting converted to an proper datetime format. So wherein the datetime is get sorry the data part of the text is getting like is not getting converted to an correct format. So I'm not sure how to fix that. So if you see here, it's standard across all the datetime values. Yeah, so I think I ran this optimize sometime back, like a few days back for this table. Okay. All right. So next, what we're gonna do is that I'm just gonna quickly run a vacuum operation on one of the tables. So let's run it for the NYC taxi table, and we'll see if my process is able to track this vacuum command or not. So what I can do is that I can rather delete these files, or I can keep the existing file as is. So what any new data that is generated gets appended to the existing data. So this would basically help you to identify, track the statuses of the metadata changes and the operations that have been performed. Okay, so it's done. So I'll rerun this. So again, it's gonna prompt for our browser credentials because it's a new run. So it's processing all the tables all over again across every lake house. So what we can do is that we can just like instead, if you don't want to run it across all the lake houses, so you can just like uh, there's a configuration here where you can mention the lake house. I think it's better I put the configuration into the app settings.json. So it will rerun only for the lake house that has been set in this variable. Okay, so I started the process for NYC underscore taxi. I think half of the time is it's, it takes time to like to get the response from the from the API. All right, so this is the process completed. I think it took around a minute, or not. I mean, around 45 to 50 seconds to process that one table. Okay, let's open this. Yeah, so as you can see, the data got appended for this new run. Yeah, so we had ran it on the NYC underscore taxi, right? So now you should have a detail for a vacuum operation. Yeah, so this is the vacuum operation. All right, so again, this is the same issue. Not sure how to handle this. Yeah, so you can see that we had ran the vacuum operation and it has correctly tracked the vacuum operation that was run on the table. Okay, all right. So and that's all for this walkthrough. So I hope this helped you understand like how the entire process runs and what are the different aspects that you should consider while running this process. Right. If you do have any questions or comments, do let me know. I'll be very glad to answer them. Okay. Well, thank you very much.